Alright, Math 3, Unit 2A, point 1.3 practice. Okay, now we've added and subtract. Now we're going to multiply polynomials. Okay, so the way you learned about how to do this was last year. You did a lot of this stuff last year. And you found, or hopefully found, the connection between factoring and multiplying. Or in other words, the connection that they're opposites. Okay, and we have what we call the area model, which is a great way to go from multiplying to factoring or factoring to multiplying. Okay, it works both ways. If we want to multiply, we put our variables and numbers on the outside, then multiply it in. Okay, if we are given the end result and we want to factor back, which we'll have to do later on, then we're given numbers and variables in here, and we go backwards, we pull stuff out, stuff that they share to get our answers. Okay, so we're going to practice the multiplying here, which is good for as we get going. We're going to have to go backwards. So if we know where we're coming from, it's easier to go back to where we're going. Okay, so here's how we do it. We've got two parentheses, and there's each a term in each one. So I take my first one, and a plus is a positive 3. A minus, or in this case a minus, is like a negative. So I make a box, and I cut it so each one of these vertically has its own column. And then for my second one, I line them up vertically, and then I cut them so they each have a row. So 4 terms, 4 boxes. Okay, so then I multiply. So the first one would be multiply here and here. So 11x times negative x squared. Now remember, we talked about when we were adding that x squared really is x times x, and x is like x. Well, if I multiply x with x times x, that gives me 3x's, which a shortcut way of that repeated multiplication is x cubed. So that becomes x cubed. So we take the powers essentially and add them. Then 11 times negative is negative 11. Okay, then I multiply down here with this one. 11x times 7. 11 times 7 is 77. No other x's, so it just stays x. Then we multiply across here and down here. 3 times negative x squared is negative 3x squared. Variable doesn't change because we don't have any more variables. Then finally we multiply 3 and 7 to give ourselves 21. Okay, then we simplify, just like we were doing at the beginning. So, are there any other x cubes? No, so I go negative 11x squared cubed. Are there any other x squares? Nope, so negative 3x squared. Once again, we still go in that order. Okay. Any other x's? Nope, so plus 77x. Any other constants? Nope, plus 21. And that is the multiplied version. I can't simplify it any further because these powers are different, remember. Because we're adding or subtracting here, we're not combining those. Okay, it's not like we did up here where we were multiplying them. So that's as simple as we get. And that's all it wanted us to do, was simplify the expression. Okay, so let's take a look at number 2. Now number 2 is slightly different because instead of 2 terms, I've got 3. But I treat it the same way. I make a box. I give myself 3 columns this time. Okay. Then I've got 2 that it's multiplied by, so I have 2 rows. Okay. Which now you'd say, well, that gives me 6 boxes, but I only have 5 terms. That's all right, because you're lining up, think more rows and columns, and I probably should have said it that way before. Okay, so then same idea, this times this, then this times this, then this times this, then this times this, this times this, this times this, can I say this times this, and this, and this, and this, and this, and all that. Okay, so we start off, so 6x cubed times 2x cubed, x cubed times x cubed would give us x to the 6th, 3 plus 3 is 6, right? X times x times x, times x times x times x. There's 6 of them. Then 2 times 6 gives us 12. Okay, next one. 5x squared times 2x cubed. So we get x to the 5th. 5 times 2 gives us 10. Then we go this one. Negative 1 times 2x cubed. Negative 2x cubed. Okay. Then next up, we go down here. 6x cubed times 4. 6 times 4 is 24. X cubed. Okay. Then 5x squared and 4. 20x squared. Okay, then negative 1 times 4 gives us negative 4. Now I look for things that are the same. Okay, highest power first, highest degree first. 12x to the 6th, no other x to the 6th. That one goes in first. What's my next power? X to the 5th. No other x to the 5th, so 10x to the 5th goes second. Next power would be negative 2x cubed. There is another one, 24x cubed, so let's combine them. Why write them twice? Just have to combine them again, because we're trying to simplify here. So negative 2 plus 24 would be positive 22x cubed. Okay, cross those out. Then next up, 20x squared, and finally minus 4. And there's my simplified version. Notice I put my powers in order. How many terms are there? 1, 2, 3, 4, 5. Okay, in my polynomial, what's the degree? Degree of 6. Can I simplify it further? Not unless I know what x is. Okay. Alright, now let's just keep busting it out. Number 3. Negative y squared and 10. So 2 columns. I want to give myself more room on that one, don't I? Okay, 2 terms here. 8y cubed, 2y. So give myself 2 rows. Then I start multiplying. Negative y squared times 8y cubed. Negative and 8 would give us negative 8. Y cubed and y squared, y to the 5th. 10 times 8y cubed, 80y cubed. Y squared times 2y would be a negative 2y cubed. 2y times 10, 20y. Now notice we once again have the same powers. Highest first, negative 8y to the 5th. There's no others. We're done. Negative 2 and 80, positive 78y cubed. Cross those out, and the last 20y. And there we go. And that should be an 8. Okay, now let's look at 4. Okay, this time we have 2 on top, and it doesn't really matter where you place them, which one's on the top and which one's on the bottom. It doesn't matter. Okay, typically I just put the first one we go into, ends up being on the top for me. Why? Because that's just the way I roll. So we get those two, make 2 columns, and we've got 3 terms here. And if it's a minus, remember, think of that as a negative. So now we have 3 rows. Then we start multiplying. 2x squared times 10x to the 5th. 2 times 10 is 20. X squared times x to the 5th, x to the 7th. 4x squared times 2x squared. 4 times 2 is 8. X squared times x squared is x to the 4th. Okay. Negative 6x times 10x to the 5th. Negative 6 times 10, negative 60. X times x to the 5th, that's like to the 1st, so x to the 6th. Okay. Negative 6x times 4x squared would be a negative 24. X cubed. Get another color here. 10x to the 5th times 3. 30x to the 5th. Then 4x squared times 3, 12x squared. Now notice here, none of our powers lined up, right? So we can't combine any of these. We've just got to write them in order. Okay, so our highest is 7, then 6, then 5, then 4, then 3, then 2. So there's our order right there. So 20x to the 7th minus 60x to the 6th. And you could put plus a negative, but minus looks so much more beautiful. Plus 30x to the 5th plus 8x to the fourth minus 24x cubed plus 12x squared. So a very long polynomial with a degree of 7, but sometimes multiplication gives you big things. Okay. Alright, number 5. So 3 on here for this time, so 3x to the fourth, positive 5x cubed, negative x squared. So 3 columns, okay, and 2 rows. So x cubed, negative 6. So we get negative 3x to the 7th, 5x to the 6th, not the 9th, don't multiply these, add them, and negative x to the 5th. Then we get positive 18x to the 4th, and I know I'm going kind of fast, but I figured I went slow enough on the others, so you should be just checking your work now. Negative 30x cubed, and positive 6x squared. Nothing matches up, so I just rewrite it in the order highest degree to lowest degree. And that's all there is to it because I can't simplify any further. Okay? Alright. Now number 6 is going to get cray-cray here. And I just said cray-cray on my video, which makes me seem really weird because like I'm trying too hard. So I apologize for that. Okay, but we do it the same way. There's 6 up top. Or I should say 3, so 3 columns worth. But there's also going to be 3 rows, aren't there? Because we've got 4y cubed, y squared, negative 1. Alright, so then we start multiplying. 7 times 4, 28, y to the 6th, y to the 3rd, y to the 9th. Negative 9, y to the 4th times 4, so negative 36, y to the 7th, 2 times 4, 8y cubed. Okay, and the next one down, 7y to the 6th, y squared would be 7y to the 8th. Negative 9y and y squared would be negative 9y to the 6th. 2 and y squared would be 2y squared. Okay, 7y to the 6th, negative 1, negative 7y to the 6th. Negative 9y times negative 1 would be positive 9y to the 4th. And then 2 times negative 1 would be negative 2. Okay, do we have any that match up? 9, 8, 7, 6, and 6. No 5, then 4, then 3, then 2, and then 0. So we do have to combine these two, right? Okay, but we start, and let me start clear over here on this end. So we'd start out 28 y to the 9th plus 7y to the 8th minus 36 y to the 7th. Then negative 7 and negative 9 would give us negative 16 y to the 6th. Combine those right now. Then 9y to the 4th. Then 8y cubed, 2y squared, and negative 2 for the end. So a massive, ugly-looking guy, a degree of 9, terms 1, 2, 3, 4, 5, 6, 7, 8. Okay, that would be like an octanomial, fancy polynomial with 8 terms in it. And there we go. Pretty crazy, huh? Alright, so the last one's going to look pretty similar, isn't it? Because it's got the same amount of numbers. So, we know right now that I'm going to have to make a 9 by 9, huh? I guess 3 by 3 for 9. So 5x squared, 4x, 3, 7x cubed. This is good practice, though. You should be well versed at this when we get through. Alright, here we go. So this times this, this times this, this times this, this times that one times this one times that one times this one times that one, and those times together. So 5 and 7 give us 35, x squared, x cubed, x to the 5th. 4 and 7, 28, x and x cubed, x to the 4th. 3 and 7, 21, x cubed. 5 and negative 5, negative 25, x squared, x and x is x cubed. 4x and negative 5x, negative 20x squared. 3 and negative 5, negative 15x. Negative 2 and 5, negative 10x squared. 4x and negative 2, negative 8x, 3 and negative 2, negative 6. Now if we look at this one, we have 1 term to the 5th, 1 to the 4th, here's an x cubed, and here's an x cubed, here's an x squared, here's an x squared, here's an x and an x. So we got to combine some of these so it won't look so ugly. So start off with our highest, 35x to the 5th. That's where we start off. Okay, then 28 plus 28x to the 4th. Okay, then I can combine negative 25, positive 21, negative 4x cubed. Then squares, negative 20, negative 10, negative 30x squared. We like being able to combine, don't we? Negative 8, negative 15, negative 23x, and then lastly, negative 6. And there we go with that one. Woo! Pretty crazy, huh? So, 8, 9, and 10, last time we dealt with perimeter, where we just added them. Now we're dealing with area. Area, right? You have length and width. It's length times width. Gives us area, and it's square units. So, same idea here. Instead of L and W, we have x plus 8 and 3x minus 2. So, and then multiplying them, so I'd go x plus 8 times 3x minus 2. Okay. Well, here's a cool thing, and I don't know how this will come out, but let's say, look at our area model, and this is why it's called the area model. Okay, that's like 3x minus 2. I multiply those two pieces, I find out what the area of that piece is. I multiply those two, it's like I created 4 extra little rectangles. Okay, I find out what that equals for that little area, this area, and this area. Okay, if I could break them up, it'd be like x and 3x, be like 3x and 8. It would be like trying to build connections here. It'd be like negative 2 and x, and then it would be like negative 2 and 8. And I would multiply each of these separately, right? 3x times x, 3x squared. That's the area of that piece. 3x times 8 would be 24x. That's the area of that piece. Negative 2 times x, negative 2x. Negative 2 times 8, negative 16. I've got these 4 separate areas, which then I add them together like we did last time with, or the first time, okay? 3x squared plus 24x plus negative 2x plus negative 2. Then I'd simplify. 3x squared plus 22x minus 2, and that's the area. And that's why we call it the area model, because that's essentially what we're figuring out is the area of that. And then we get to the point, like you did last year, where you take this and you split it up to this next piece, and then you put the areas in here and say, okay, what would this have to be to work out for each one to match up my numbers? Okay, that's why it works. Anyway, there's the answer for 8. So let's do 9 and 10. Okay, so I'm just going to draw it like this. So it's like we got 4x plus 10, okay, x squared plus 1, which we write them as multiplied, right? But then we would just go back and make the area model again, wouldn't we? So we might as well just start out doing that area model, huh? Okay, which is why it's called, once again, the area model. Now, it doesn't matter which position I put them in. X squared times 4x, 4x cubed. X squared times 10, 10x squared. 4x times 1, 4x, 10 times 1, 10. This time we can't combine any like terms, so we just write 4x cubed plus 10x squared, highest degree to lowest degree, plus 4x plus 10. Polynomial of 4 terms to the 3rd degree, with coefficients of 4, 10, and 4, and a constant of 10. Aw, yeah. Okay, one more to go. So let's start off. We're going to make our area model. Okay, so this would be like our length, 6x plus 5. It would be like our width, which if we really wanted to, I could write it like this, 2x cubed minus 3. But I think it's a lot easier to just go 2x cubed and then minus 3 here. Okay? So, 2x cubed times 6 would be 12x to the 4th. 5 times 2x cubed, 10x cubed. Negative 3 times 6x, negative 18x. Negative 3 times 5, negative 15. So I write it highest degree, 12x to the 4th, plus 10x cubed, minus 18x, minus 15. And there